So in this exam tile question, we're told that a cell of EMF 9 volts and internal resistance R is connected in the circuit shown below. So that's this circuit here. If you're wondering what this grey box is, that's just how we represent a cell. You might see this with dotted lines in an exam style paper. That's just one way of doing it. You don't have to do it like that, but that's just kind of the terminology they might seem to use in some questions, and so we've adopted it here. You might see it with dashed lines instead of this solid line, but we've gone with this solid line. So that's just our cell. So this is our EMF of our cell, that's what that's representing, and this is the internal resistance of our cell. And then we see we've got these two components here connected in parallel with each other, and this component connected in series with this parallel combination. So what do they want us to do? Well, we're told that the current in the battery is 1.2 amps. They'd like us to calculate the potential difference between points A and B in the circuit. So this is relatively straightforward. We've done this thing quite a lot. We know that we just need to find the total resistance of these two components. We'll call that RT. And that's just going to be, remember, well, we know that we've got the formula 1 over RT will be equal to 1 over this plus 1 over that. That gets us an expression for the resistance here. And then we know from basically from V equals IR, we can find the potential difference. So let's just write this all down. So we know that the total resistance of those component of that parallel part of our circuit will be given by, well, 1 over RT equals 1 over 1.5, 1.5 plus 1 over 1.5, which is clearly just 2 over 1.5, which is again going to be 4 over 3. So what we can do there is we can just flip it upside down and get our resistance. So that tells us that RT is just going to be given by the inverse of this, so 3 over 4, which is 0.75 ohms. So what do we do now? Well, we know the current, and we know the resistance, and we know that the potential difference obeys V equals IR. So V is going to be equal to IRT, where that's our total resistance of those components. So the total potential drop here, V, is going to be given by 1.2 times 0.75, which is going to be 0.9, excuse me. So that's going to be 0.90 volts. And that's the potential difference across these two. So we can write that in as our answer, 0.90 volts. So the next thing they'd like us to do is calculate the internal resistance R. Now, how do we do that? Well, let's remember the formula we had for our cell EMF in terms of the resistance of all the outside components, which we'll call capital R. That will be the resistance of all of these components together, and then the internal resistance and the current in the circuit. So we saw that here. We found that our cell EMF, epsilon, was equal to I times little r, the wasted potential difference, plus capital I times capital R, where capital R is the resistance outside our circuit, and that's our terminal potential difference. That is to say, if we measured the...
Hey guys, to continue watching this video and unlock hundreds of other super concise and exam board specific A-level physics videos, just click the Snap Revise smiley face. Join me today, and together let's make A-level physics a walk in the park.